Hello, hello, everyone. Welcome to the second VMware Code Community Hour. Um, I got to come up with the shorter name. It's just too long. It's just too long. But yes, with us today, we have Ian, Alper, and Ravi. They're on the performance team, actually, on the VMware Cloud Foundation performance team. Somebody brought it over to my attention. I believe Julie Brodeur. Is that how you
Julie
say it?
Brodeur. Yes. Yeah.
Perfect. Super. She brought this over to my attention. There was a VMware vCenter 8 update 3 tagging performance best practices. Right. So there's a brand new document that came out that they were able to put together. So they are the authors. Last week or 2 weeks ago, during our first code community call, tagging was brought up. Right. This is the fun part, all right, yeah, about these quote unquote hallway tracks where yeah, you kind of get out of a session and then you get to talk to customers and just peers, right? Just other practitioners, and you get to see what's interesting to them, right? Something that you maybe never even thought of. And tagging came up, right? It's such a kind of nerdy thing, but it was fun because when I was a customer, I used custom attributes. And then like tagging, I was like, well, tell you what do I want to use tagging for? Like I got to figure it out now. And it was just something else for me, right? And I didn't see the immediate benefit. So then I was like, why waste my time? But after speaking to these community members, right, and now kind of learning about automation and infrastructure as code, it's like, whoa, if you're not doing tagging, you're not doing it right, and that is absolutely where what the session is for, right? We want to be able to let you know, okay, if no matter where you are in the journey, right? If you're brand new to PowerCLI or infrastructure automation, or if you just want to improve what it is that you're already doing, no matter if you have 100 VMs, right? A small environment, or if you're running 10,000 VMs, right? This is definitely the group to ask, and yeah, hopefully you learn something. So without further ado, I'm going to hand it over to Ian, Alper, Ravi. Go ahead, and community, feel free to post questions. Yeah, feel free to post questions here in the chat. And if you're over on Discord and you don't want to speak up here either, please post questions and I can just transfer them over to the call. But yeah, take it away. Thank you.
Sure. First of all, thank you very much for the invitation, Franky. I really appreciate it. And I checked the VMware Code Community website before I came here. There's a lot of cool stuff. So it's really an honor to be here. The other thing I wanted to say is if customers have questions, comments, feedback, they wish they had an API, whatever, if they connect with you, you can connect with us and we'll see what we can do. So just wanted to get that out there. Okay, great. So as you mentioned, Alper, myself, and Ian are all members of the VCF Performance Team. I will say a little bit of preamble, then I'll hand it over to Alper and Ian to both introduce themselves and add some additional content. So I've been with VMware and now VMware/Broadcom for about 21 years, I think, working on vCenter performance and scale, etc. And just specifically with respect to this tagging white paper, the genesis of it was actually back in 2019. We have a person we do a lot of large scale testing. At the time, it was just vCenter. Of course, now we're looking to incorporate, VCF, et cetera. But one of our colleagues was doing a lot of tagging related calls, and I noticed that they were really slow. And so I looked at the tagging code and I spoke to some of the developers, and we noticed that he was using PowerCLI. And while PowerCLI commandlets are super easy to use, the trick is that just in order to make them easy to use, they have to collect a lot more information and do a lot more validation than you would need if you're trying to write highly optimized code. So we started by writing a blog back in the vSphere 6.7 days about tagging. And what we said was, hey, you can use the commandlets, or you can use some of these newer APIs directly within PowerShell. Unfortunately, it's not as easy to do that, which is one reason we wrote the blog to say, hey, if you want better performance, do this. This eventually evolved into a white paper for 6.7, where we said, okay, we've noticed that customers, some of the common commands that customers do are, if they're trying to use tags, is they need to attach a tag to a VM, to a host, whatever. They need to list the tags in their system. And we wanted to sort of help customers understand how those sorts of operations performed. So we ended up writing a white paper back in the 6-7 days showing the baselines. And at the time, there also wasn't any, there weren't any published limits to tagging. Customers would say, well, how many VMs can I have? How many tags? Whatever. And we still don't have official documentation because official documentation suggests that if you exceed a certain limit, things will break. But for tagging, what ends up happening is if you write your code carefully, you can get to a certain level. If you write even more carefully, you can get higher than that. And so it's a matter of graceful degradation rather than stuff breaking. So that's one reason we don't publish official limits, but instead we try to use this white paper to indicate, hey, if you write things well, this is what you can achieve. So anyway, we wrote that paper in 6.7. And then we refreshed it for 7.0. And what we realized at the time we were writing the 7.0 white paper is that there were a number of performance improvements as the tagging infrastructure backend has evolved. So we used to use 6.7 primitives. In 6.7, we would use data sharing similar to how linked mode is implemented, but in 7.0, we started pushing things into the core VCSA, and we started updating how we use the database. Now, fast forward, we wrote one for 7.03, get even better performance, and now we've refreshed it for 8.0. And so what we've tried to do in this paper is give a sense of the history of the operations and how much better they've gotten over the years, as well as kind of giving you guidance as to how you can best take advantage of the tagging APIs. So with that, I'm going to pass along the baton to Ian.
First, yeah.
And Ian is going to talk a little bit about some more details on the tagging white paper. Okay, go ahead, Ian.
Okay. So hello, everybody. My name is Ian. Thank you very much for inviting us to join this. This is a very good opportunity for us. And I've been here in VMware Broadcom since 2021. Right. So just to start things on, I will just give a very brief overview on what we actually say in the paper in terms of kind of a little bit more detail to build on what Ravi just described. Now, I mentioned, I noticed that a lot of you mentioned about PowerShell. In this specific paper, the figures and the numbers we generate, we actually use the Java SDKs, right? And in addition to that, although we don't show it, in our test, we actually also test all these APIs using Python directly connecting to those REST endpoints, right? So there's actually, and we also, obviously, we mentioned PowerShell in the paper too. So there's multiple ways for us, for any user customers to use these APIs. Okay, now having said that, actually, Alper, can you share the paper on your screen? So it's like, it's not going to be like some crazy stuff. Okay, so kind of to build on what Ravi just described, the whole paper, there's kind of like two main points that are kind of shown in the paper. So one is some of these some best practices in using these various APIs, and also what kind of Ravi just mentioned earlier about the history. Since this is a kind of the 8.0 version of the white paper, we mentioned some of the performance improvements that are introduced in 8 compared to the previous version of vCenter, right? So I'll focus on these two as I describe some of the APIs we cover in this paper, right? So actually, Rob, can you just go to the kind of the table of contents? Yeah. So first, the first API we kind of covered is the tag creation API, right? And basically, I'll be very brief on this one because in this one, 7 and 8 doesn't really have a big performance difference. And also, you might, for people who have already looked at the paper in detail, we only show the tagging part, creating tagging part, because the create category part is kind of similar, and we didn't want to bloat the number of kind of the pages of this paper. But if people were curious why we only show the tag creation API, is because the tag category creation APIs basically has all the similar performance considerations, right? So that's the first one, which is the tag and category creation API. Now, the main bulk, which is, I guess, is what people will find the most interesting in this paper, is the tag association APIs. Now, this is about we describing the various different APIs and how they would perform in different situations and what are suggestions as a performance kind of team, providing some best practices of using those APIs. So basically, just give a brief summary. The three main APIs are covered here is the attach API, which is attaching one tag to one object, the attach tags to multiple objects, which is giving one tag and then a list of objects, and then attach multiple tags to object, which is giving a list of tags and then one object. There is no multiple to multiple API. So it's one tag to many objects or many tags to one object.
Can I make a very short interlude?
Yeah.
If you look on the screen, we acknowledge, by the way, at least among the three of us, that these APIs are super confusing. So just to summarize what Ian just said, you can do a single attach call, attaching a single tag to a single object. Or if you look right in the center of your screen, and if you're on the phone, if you're in the car, please don't look. The two calls that Ian just referred to are attach tag to multiple objects, where you take a given tag and then attach it to a bunch of VMs or hosts or whatever at once. Or the second one is attach multiple tags to an object, which, as Ian said, you get a list of tags attached to a single VM or host. And as he said, there's no sort of all-to-all thing. The reason we focused on these is in the very first incarnation of this white paper, as we were doing some of these operations, we realized that there were dramatic performance differences between these different APIs. By the way, I should give credit to our colleague Raju Angani, who helped with the first version of the white paper, and with our colleague Maarten Wiggers, who also helped. With that, let me pass it back to Ian. Ian, sorry, go ahead.
Okay, right. So as these three APIs basically are the tools you have if you want to attach a certain number of tags to a certain number of objects. Now, the one-to-one API, which is the attach API, generally, because for every tag to object pair, you have to call once. This API, as we show in the paper, generally doesn't scale as well as the other two, which is kind of more of a bulk API. Now, so generally in most situations, if you have multiple tags and multiple categories, you would usually use one of those two bulk APIs instead of the single attach API. Now, regardless of the other two, so although
let's do one thing.
Sure.
Alper, please go to the chart that shows the performance difference between attaching a single VM to a single object and attaching multiple. I think that's going to illustrate your point, Ian, really well.
Actually, can you show that the last one, the final table? There's a table. We have a table one that has a kind of summary.
Oh, perfect. Yeah.
The score around.
Yeah. So to summarize, what Ian is saying is that you can attach a single object to a single object, like a VM, to a single tag, or you can attach a tag to multiple objects or multiple tags to a single object. I know it's confusing, but this table here shows the dramatic performance difference.
Right.
Go ahead, Ian.
Right. So
Table 4.
Yeah. So this is we have multiple scenarios when we say, like, in general, if we say one tag to many objects or many objects to one tag, and this is the kind of the more of a summary table that we kind of show in the end of this section, just to kind of summarize how these three APIs perform under kind of as we scale up the number of tags and categories. This is a kind of like a 1,000-feet view where you can have one view on the difference in performance.
And so just, you might, since someone might be in their car, can you read to him the last column so that he can get a sense of the differences?
So for example, okay, just to read the last column, right? So if we were to attach 20 tags to 10,000 VMs, which means we're creating 200K associations, the attach API takes about 34 minutes. The attach tag to multiple object API takes about 4.6 minutes, and the attach multiple tags to object API takes about 2.7 minutes. Now you can see that, as I kind of mentioned earlier, the attach just kind of doesn't scale as well. It takes much longer because there's so much more calls you have to make. Now the other two APIs, in general, our performance numbers indicate that if you have multiple tags and multiple categories, you might just want to stick with attach multiple tags to the object API. But since these APIs kind of depends on how many tags and objects you have in this your system, we mentioned in the text too, that if you have kind of different scenarios, on one of these two APIs might be performing better in your like specific situation. So that you want to kind of, you don't want to just blindly use one, but you want it based on what your kind of situation is.
Yeah, what we tried to do in this paper was really say, here's how the different APIs perform. For this use case, you want to use this one. For this use case, you want to use this one. And the other thing I'll point out, which Ian alluded to, is many of the benchmarks we write have been written in Java, but the same applies if you're using PowerShell or Python, with the caveat that if you're using PowerShell, many of these need to be direct API calls as opposed to commandlets. And in the paper, we describe what that means. So with that, sorry, Ian,
Yep.
do you want to move on to list attached tag?
Yeah. So
I
okay.
think the most probably effective way to talk about that is just to show them the picture.
Yeah. So before, just for a minute. So before I go to the next API, which is the query API, just a brief summary of the performance differences that we saw from on these three APIs from version 7U3 to 8U3, right? So basically, because of the performance improvements made by the tagging team, in general, we see that the attach API calls is about 40% speed up. The attach tag to multiple objects call, this is the one that has a very huge, it's about 200% speed up, which means they cut the time about to 1/3 of it. And then the attach multiple tags to object call shows about 30-ish% speed up. So all these things you can, if you want more detail, you can see the paper. We summarize in various situations where these kind of performance increase occur. All right. So having said that, let me go to the query association APIs, which is we have a bunch of associations we already created in a system. How do we kind of retrieve it as a user, right? So Alper, can you go to the graph? There's a bottom, a little bit bottom. Okay, yeah, this one. Yeah, okay. So the way that's provided to us now in vCenter to list these associations, there's a few, right? There's list attach objects on tags, which is give the API a list of tag IDs, tell me all the, and give me all the associations, and like, actually, give me all the objects that are associated to those tags, and this, and while you're doing that, you will get all the kind of tag association objects, right? And the second one is list attach objects, which is give it one tag. The one previous API was give it a list. This is give one tag, and it will also give all the objects associated to that tag. And the third one is list attach tags on objects, which is kind of flipped from the first one. Instead of giving it a list of tag IDs, you give it the list of object IDs, and it will give you back the tag IDs. And then in that process, you will have all the associations from that list. And then the fourth one is list attach tags, is you give it one object and will give you the list of the tags associated to that object. And there's a fifth one, which is slightly different, that this is actually a newer one compared to the other APIs, which is a page-indented list, is where you do not give it any tag ID or object ID. You just say, give me the list of all the associations in the system, and give it you don't have to give it, but like it will return a list of associations that are paged, and the default page size is 5,000, and this is a variable you can change. So
can I just add a note here? As Ian kind of just described, there's a lot of different ways to query for a given VM what tags are affiliated with it, and for a given tag what VMs are affiliated with it. Some of those are basically unbounded. If you say list all attached tags, you'll get every tag in the system. If you say list attached tags on objects, it'll give you every object associated with list attached tags on objects will give you every tag associated with a bunch of objects. The trick is, because some of these are unbounded, they can overflow buffers within vCenter. And so you have to be somewhat careful to limit the request sizes and response sizes that we're using. And we talk about this in the paper. As Ian indicated, in 7.0, the solution that was provided for this particular issue was providing a pagination API. In the pagination API, instead of you having to sort of think about your objects and your tags and say, okay, my results set is going to be this size, so I'm going to make sure my requests only return these many objects. That's super onerous. Instead, if you use this pagination-based API, you can basically say, okay, just give me every association, and the system will return it to you in a size that doesn't overflow any internal buffers. And in addition, it will properly handle errors. So for robustness, you probably want to use this pagination-based API that Ian just referred to. And there are performance differences between all of these, which we list in the paper. Okay, go ahead, Ian.
Right. So just to kind of latch on what Ravi described, our numbers actually show that the pagination API is actually, in overall, is slightly slower than the other APIs. Now, having said that, the pagination API is still what we kind of, when we do this best practice suggestion, the API we suggest people to use because of the reason Ravi just mentioned. The other APIs, if you do not know how many associations are in your system, it can hit a response, kind of what Ravi was saying, the response limit of the vCenter, which is 7 megabytes. And the pagination API, because of the way it is designed, it will always bound itself to be under this limit. So you will never, the user, when using this API, never has to worry about it. Whereas the other APIs, you also have, when you use those APIs in your code, you always have to be aware of, to maybe check, or you have to do some calculation to make sure you don't actually hit these APIs to be the limit, which will break your response, which would cause an error, right? So overall, we would recommend using the pagination API if possible. Okay, so that is that. And in terms of performance differences, because there are no really performance kind of improvements done between 7 and 8 on the Curie APIs. These specific set of Curie APIs perform similar between 7 and 8.
Perfect. Now let me at this point introduce Alper, and I'm going to say a quick thing after you're done. Well, I'm going to say many things after you're done, but go ahead.
Wrap up at that.
Yeah. Well,
besides the tagging API improvements, we also show enhanced link mode performance related to tagging in this paper. So let's start with what is ELM, which is called also ELM, enhanced link mode. What is it? Let me give you a very quick overview.
Actually, can you hold on for just a sec?
Yes.
One of the reasons that we added a section on enhanced linked mode is that when we first published the white paper, it was for a standalone vCenter, a lot of customers came back and said, but wait, if my vCenter is in a linked mode configuration, do I expect to see the same performance? And so in, I think 703, we added a small section on this, and Alper then, in the latest version of the white paper, added a longer section. By the way, not to steal his thunder, but the bottom line is your performance is fine. Now with that, Alper, go ahead.
And let's look into ELM. Figure 10 in this paper shows a typical ring topology of 15 linked VCs, which is also the recommended topology for ELM. In a nutshell, ELM provides a single pane of glass. What I mean is an admin can log into any one of these VCs in this picture, and then admin can manage the inventories of all the linked VCs in this picture. Admin can view and search across all linked VCs. Admin can replicate and manage roles, permissions, licenses, policies, and tags across all linked VCs. As I just said, one of the main use cases in this picture is sharing of tags and categories across all VCs. In this paper, we studied the performance of ELM related to tagging. Let me give you a little more detail about ELM tagging. With ELM, tags and category definitions are globally shared across all VCs. Tag associations, on the other hand, are local to each VC. Tag association is the information saying that this tag associated with this object, and that information is local. But the definition of tags and categories are synchronized to all VCs in the linked mode. And this replication is done periodically every 30 seconds. Having said that, we focus on two questions in this paper. How long does it take to replicate tags and categories across all linked VCs? And what is the performance of tag and category operations when carried out against a standalone VC compared to a linked VC?
Just pause for 1 sec. Just to emphasize what Alper just said, in linked mode, if you create a tag, you replicate that tag definition across all vCenters. And so one question that we got when we first published the white paper was, hey, if I'm using linked mode and I create a tag on a certain vCenter, how long does it take for that tag to show up on another vCenter? And that's what Alper's going to talk about.
That's the first question that we focus on. How long does it take to synchronize all these linked VCs in this picture? Let's look at the figure 10 here. And let's assume at time 0, a tag is created at VC1. Up to 30 seconds later, VC1 will replicate this information to its neighbors, VC2 and VC15. And up to the next 30 seconds later, VC2 will propagate that information to VC3, while VC15 propagates it to VC14. And it goes on like that. And as the timeline suggests here, in this 15-node ring topology, a tag may take up to 210 seconds to replicate across all the VCs. This is the worst case. However, on the average case, we observe it much quicker, since the synchronization between neighboring nodes does not wait for the whole 30 seconds. And indeed, figure 13 here, in our experiments, we observed that this replication process is completed approximately between 100 to 130 seconds. That's the number one takeaway point. And the next question that we focus is comparison to standalone VC tagging performance. So let's look at the two different use cases. The first figure 14 here shows a link mode topology. Figure 15 shows a standalone VC. In both cases, there are clients that are executing workloads against VCs. Say, for example, VC1, client 1 associates 200 tags with 1,000 VMs against VC1. And there are multiple clients executing the same workload. And this workload is executed parallel. And we would like to know, how long does it take to complete this workload? It is expected that there to be no difference, since there are no dependencies with tag associations between linked VCs. And all these workloads can be run and executed parallel. And indeed, that's what we observe. In the ELM use case, we see that all these workloads are completed around 42 to 45 seconds, while the standalone VC use case, it takes about 43 seconds. So we don't see any major difference. That's the number 2 takeaway point. Having said that, I'm going to pass to Ravi to wrap up.
Oh, okay. I wanted to say actually a little more than a wrap up. I'll say a couple of things. First, can you go to the section where it shows the scale limits? I believe it's section 8 or 9. It's near the end. Section 8, yeah, perfect. So first of all, Franky, as a shout out to what you originally said, we actually put a section in here about custom attributes because people would ask us, when do you use custom attributes versus tags? And here's one interesting example, and I'm sure you can think of 100. So imagine that for a given VM, you want to have something unique, like the time that it was created. Well, you can imagine for every VM, that time will be different, right? If you tried to use tags for that, you would basically have to create a different tag for every timestamp. And that's extremely inefficient, right? You'll explode the total number of tags you have. So instead, obviously, a custom attribute is better for that. But for things where, like if you have OS type or something like that, right? Linux would apply to a bunch of your VMs. Windows would apply to a bunch of your VMs. Those are situations where you're better off using a tag versus a custom attribute. In this table that Alper has shown on the screen, what we did for our setup, which was, I believe it was an extra large vCenter, we said if you have an extra large vCenter, these are how many tag category definitions we support, tag definitions, and how many tag associations. And as Alper said, a tag association is basically if I have 10 VMs and each VM has 10 tags, that's 100 associations. If I have 10 VMs and one tag per VM, that's 10 associations. So the point is, if you tally up the number of objects you have and the number of tags you have, you come up with the number of tag associations. So these are not hard limits. It's simply that as we were writing the code, we found that whether you use the UI or whether you use our APIs, the out-of-the-box performance met our benchmark demands. So that's one thing I wanted to point out. The other thing that I wanted to point out for this, I'm going to share my screen. Yeah, I'll stop your share and then I'll share. Yeah, here it is. So as I said, one of the original things that we had done many, many years ago was to write a blog on PowerCLI tagging performance. I just wanted to give one example of what I meant by directly using the API. If, for the sake of argument, you were going to attach a tag to a VM, and if you want to use commandlets for that, what you might do is you might do a new tag assignment command. For that, you need the name of a tag, and then you need the VM that you want to attach it to. Now, in general, PowerCLI does client-side filtering. So by that, I mean that if you ask for something, like something to happen on a single VM, what often happens is that PowerCLI will pull information for every VM in the system over to your PowerShell client, and then perform the operation, throwing away all of the other results. One reason that it's more efficient to directly use the tagging service calls is that you can actually offload a lot of your computation onto the server side. And that's what we demonstrate here. We pick a single VM. When you're directly using the API, you have to use this kind of an object right here, right? You're basically doing a VM object, which is a mapping between the ID of that VM and its reference within vCenter. Once you've done that, you can directly call, in this case, the attach API with the ID of your tag and the ID of your VM. That goes to the server, does one operation, and then returns. It's very different from a commandlet, which grabs information for every tag and VM in the system, and then does the operation. So you end up seeing far reduced network bandwidth. You also see a lot lower latency. This blog, and in the paper that Alper and Ian had shown, has a number of examples like this. But I just wanted to highlight that one specific example because it comes up quite frequently. And in fact, this is, we're all in the performance team. We deal with a lot of performance problems other than tagging. And I think using commandlets in the easy way, but seeing performance issues is a common thing that we see a lot. With that, I'm going to stop sharing. I know that there's a comment in the chat. I don't know if it's a question yet. Let's see. Okay, someone good. Thank you very much, Waldemar. He added the link to that blog. I will admit the blog itself is old, but the stuff that we say in the blog carries through, as Ian indicated, whether you're in 6.7, 7.0, 8.0, etc. And so with that, I'm going to pause. And if anybody has any questions for any of us, please feel free.
When I was a customer, right, I had what I thought was a big environment until I went to explore or like a VMUG events, and like I was listening to customers like, hold on, you have how many vCenters? Oh my gosh, are you crazy? And like, yeah, you're complicating your life. And but no, right? Everybody has different use cases, and so like even running, yes, when I would run queries or create reports in my environment, it wasn't efficient, right? Because I just wanted to get things done, and it's like, you know what? Even if I have to run these commands or run these things overnight over the weekend, that's good enough for me. But then I had a conversation with Lucho, and Lucho, he's also a Broadcom, and he was telling me about the size of the customers that he deals with, and I'm telling you, these things just blew my mind, and I couldn't imagine doing what like the yeah, doing what I was doing in those environments, oh man, I would get murdered. And that is exactly you know, why I think this is extremely helpful. And for example, Don, right, so who's also on the call, we were talking about automation and probably in like tagging with it, and not just like infrastructure as code, but like the ARIA suite, but yeah, those kinds of things, right? And how this is critical to something like that.
Interestingly, our customers write much more sophisticated PowerShell code than we often do internally. So I totally resonate with what you're saying. Like what they're doing is pretty impressive. I will say one thing, that when people are using commandlets, they're getting a tremendous ease of use advantage. And if they need to sometimes we have to tell them, hey, you might have to use these direct calls. And one of the biggest differences is that instead of being able to use things like tag names or VM names or host names or whatever, you end up having to get an ID. Why is that the case? Well, the way PowerCLI works internally is if you tell it the name of let's say a VM or a tag, what it has to do is it has to go to vCenter, get the name of every VM and tag or whatever, and then filter out the VM that you actually asked for, right? And then get its ID and then do all of its operations like that. And I know, Alper and Ian, we've all done a bunch of experiments to sort of quantify the network bandwidth that this consumes. And so when you're using direct calls, you can instead directly specify the ID of the VM. Unfortunately, that's a bit onerous for many customers, in part because we don't have a notification API yet, at least, that tells you, oh, okay, this tag is no longer associated with this VM. And so we often see customers that have to periodically poll, and then to periodically poll, they go and retrieve the IDs again, et cetera. So, when people are operationalizing these at scale, what we've seen is that they're willing to do some of the high performance things we ask them to do, but it does require quite a bit of it requires quite a bit of thought, and it blows my mind too whenever I see that they're willing to go through that. So I'm with you on what you just said. Okay, with that, I think somebody was going to ask a question.
No, I was going to ask the question
Okay,
of Don, right? I'm sorry, Don, I'm going to pick on you. So Don, can you give me an example or give them an example of how you use tagging, right? And you don't have to talk about your environment specifically, just in general.
Yeah, sure. So we implemented, what we know now is VCF automation a couple of years ago, and you can't use VCF automation without tags, really. Between constraint tags and capability tags. And so part of our design is data stores it's kind of like an opt-in versus a implicit opt-in system. So if we say we only want to target certain data stores, to permit VM deployment, those data stores have a tag, true or false, allow deployment, right? Or perhaps it's also by site, what site is the data store in? And that's going to help the capability, I'll say engine, but it's probably not quite that, but that's going to help automation figure out the best placement options based on, based on those tags, make sure it goes to site A, make sure it's on a data store that permits builds, etc. I was telling Franky that some of our, custom attributes, to your point earlier, are things that are very unique. A request number that links back to our CMDB, or the name of the person who built the VM, the name of the application that the VM serves, things like that. You don't necessarily, to your point, want super unique values as tags, because then you're going to have a million of them. So we want to try to keep things that apply to many VMs potentially as tags, site, department, cost centers, things like that.
I can just
right, and there's more and more. That's a great example, and as you exactly pointed out, there's more and more policy-driven stuff that's occurring with tags now as well. Sorry, I think Maarten was going to say something.
Yeah, no worries. I was gonna go on what Don said with the application. We actually do use tags for that, because we use that in the policy that we create for NSX, and use tags in that way. So there's a lot of different use cases to do the same exact thing, but just use it in a different way to your advantage. Yeah.
We've definitely seen customers try to operationalize it, and they use it in a lot of the ways you guys are describing, you folks are describing. So the one thing I would love to get feedback on at some point is how many tags you tend to have per object. right? Whether it be a VM, data store, et cetera. Because when we created this document and we said, I think 150,000 associations, or we were kind of in our mind, we were thinking, okay, imagine you have, I don't know, like 5,000 VMs and like, 30 tags per VM or whatever. But it'd be great to sort of understand how you're, what you're doing.
We're not that big of a shop. We only have about 1,300 VMs in our largest data center, and we average about 9 to 12 tags per VM. Mainly driven by what we need in the NSX policy. So
Right.
it just expands or decreases depending on what we need there. But we also put a lot of custom attributes there, like Don said, with the request number and all that stuff. So I think 10 is about a good average. I can see that number going up going forward, but for now we're still going through the process of the whole microsegmentation thing. So maybe once we onboard more stuff. But we just tag VMs actually.
This is really good feedback, Maarten. And I'm gonna bounce off you back to Don for a moment. Don, when you're using automation, at least in the past, I think it still does this, would create a bunch of vSphere specific tags, which then increases the number of default tags you have per VM. Does that factor into any of your how you structure tags?
So you're talking about automation creating the tag for you and kind of
Yeah.
imposing it on the.
Yeah.
I don't permit it to do that. I usually create the tags myself in vCenter, and then I'll reference them in automation. But I don't like for automation to do it by itself.
Got it. Okay, this is good feedback. I mean, the other thing that we've been talking about it's not there yet, is one of the, frankly speaking, onerous things is that at the time you create a VM, you can't, like, as part of the create workflow, you can't also create a tag and associate with. So that ends up being a two-step process. Luckily, that matches, Don, with what you're saying, but I personally think it would actually be a helpful thing to be able to couple those two. But if customers don't think that's interesting, maybe we shouldn't. Don, would that be something you'd appreciate, or you think it's useless?
I think I would need some more information to see how it looks I'll say in practice, but maybe more in theory, to understand what it's really doing under the covers, and then how that's going to appear to me, because I don't necessarily want too many tags appearing in vCenter if they're not. I know automation is integrated and therefore they're relevant, but I want to have more tight control over that, and to ensure that in our case, the reason we're so tight on the control there is because we came from when it was ARI automation SaaS. And so there were, sometimes fairly significant replication timing differences that, you may not necessarily be a fan of. And sometimes there would be a tag that was created. If it was created in automation, it didn't necessarily sync down to the vCenter.
Yeah.
And so we saw some odd behavior that way. And so we prefer to have, again, just out of our experience and preference, we prefer to create the tag in vCenter, let it sync up to automation, and then we'll use it there. And that way we know it's replicated accordingly. We know that it's behaving the way we expect.
Awesome.
It's interesting. I work with Maarten, so we share the environment. I feel like we do the exact opposite. I can't imagine that we'd be manually adding tags to VMs we create. For us, we essentially already assign them. Yeah, technically we do, but it's part of our creation process. We try to do most of our creation through Terraform these days, and we just assign the tags as we build, or as part of our deployments. So
Terraform is not in your environment consistently assigning the tag at the time of creation?
Oh, it is.
No, it is. It is. Yeah, no, we wouldn't want it any other way.
For that.
Right.
Sorry.
Right. Yeah, some of our tags are assigned, most of our tags are assigned that way as well, at the time of build.
But yeah, indeed, and the tags themselves, we create those through Terraform as well. So we have a dedicated folder, I guess, sort of where we manage the tags and the tag categories that we want to exist, and quite a few of the values as well. We don't limit all of them per se, but quite a few specific values. Like, yeah, no, you don't get to choose. You don't just get to randomly add tags here, like stuff like domain. You don't get to just choose what domain it is. This is one of the domains we use internally. But yeah, some of those we just have them as free, as sort of freeform fields categories we do enforce through Terraform as well.
Yeah, so actually, I do have a quick question. It's interesting that I have a question to you, Don, is that you mentioned in your automation that you are doing associations to data stores. The one thing I didn't mention earlier, one of the sections in our paper, we actually describe how tagging associations perform doing against a data store and against a VM and host, which is basically the major use case. So I'm just curious, is in kind of in your environment, how much kind of the ratio, how much do you see tagging associations do you do against VMs and to the non-VM and host objects, like in terms of is that just maybe a small proportion, or like it's actually a big thing?
It's pretty small. So we don't currently have a use case for tagging to a host level. We tag at the cluster object level, and that's only currently 2 tags. Really, it's the site code and then what the name of the cluster is, because we do some placement targeting that way. For the data store level, I'm just double checking myself. It's more or less the same. In that case, I'm targeting the I don't like that one. Let's see. Let me look at another one. Yeah, that one I'm using roughly 4 tags. So I'll have the data store, I'll say it's not always the name, but the name or the data store code as 1 tag, because sometimes we want to target a specific data store for placement. It happens. The site code, we talked about that. Allow new builds, that's my opt-in system. If it's tagged with true, then it's opted in. If there's no tag, then it's not in scope. And then what storage medium it is, if it's spinning disk, if it's NVMe, SSD, because that influences placement as well. But that's it for at the data store level.
Yeah, we definitely, as Ian alluded to, we've optimized the VM and host thing because those tend to be the largest number of objects in the system. But it's actually really good to know that your use case is slightly opposite, where you're tagging more on the data store level than the VM and host level, or at least
On
on
the VM level, even around for VMs, it's around 4 or 5 tags as well.
Okay.
That could influence the backup schedule. I have a tag for if the VM was built with VRA or not, or I say VRA, but automation, because that influences operations reports, things like that. So there are some, I would say, in our environment currently, an equal number of tags applied to VMs as to data stores, but none to hosts currently.
Oh, okay, that's very good to know. Just as I will ask one thing though. For most people, when they're doing automation and they're writing their own code, which languages are you using?
My
PowerShell.
main go-tos are PowerCLI and Terraform.
Perfect.
I think
Okay.
Everett's the weird one here because he's a Python guy.
Python guy. I just do more than VMware for most of my stuff, so PowerCLI is usually not an option for me.
That's many of us use Python internally. Well, those basically match what we use internally, so that's actually a very good thing. Not as many people use Java for at least for tagging for the new APIs.
No, I was just gonna ask what does your team have coming up next? What do you have in the works? All right, now that you finished this, what is the very next project that you're working on? What's the very next performance paper? Because we need more.
Oh, Franky, what a great question. So let me give a high level picture on that because I'm not, well, actually, do you guys have any papers in the works? Probably you're just starting up projects, right? In general, the kinds of papers that we have, there is a general vSphere performance best practices paper that gets updated with every release. Now, quite honestly, that's like an 800-page paper, but it's got a bunch of useful information. There are folks that are writing papers, and I think these are all on the vRoom blog. In fact, by the way, let me just go there right now to find it and put it in the chat because it's such a useful resource. Let's see here. Here it is. Now let me post this in the chat. Great. Okay, so what types of stuff are we doing? There's a lot of work that's going on AMD not versus Intel, but AMD compared to Intel. So that's more on the platform side. There's a lot of stuff going on in terms of AI performance on PAFE. There's a lot of stuff going on in terms of sorry, I lost my train of thought. Memory tiering. And personally, what I focus on, and I'm trying to figure out, there actually are two things I'm thinking about, but I haven't decided yet. The first is I've done a bunch of blogs and stuff, and we've done a bunch of blogs and white papers on concurrency in vCenter. How many operations can you do at once? That to me is a VMware code topic all of its own. If you want me to talk about that, Franky, sometime, I'm happy to. But there's a lot of confusion because there are global vCenter limits. There are also per host, per data store, whatever limits. And so customers will often come back and say, yeah, I'm trying to do a bunch of backup jobs. Why am I not getting the numbers that your papers show? And it's kind of a subtle, it's typically that the limit that they're hitting is not a vCenter limit, but it's a host limit. And so they have to shard their operations across hosts or across data stores or whatever. But that's something I'm kind of looking at. The second one, which I'm curious to have feedback on, is as our customers are moving to VCF, right? I, for one, as a performance person, I haven't been using VROps or ARIA as much as I've been using just typical vSphere tools. But as I've been using VROps and VCF ops, I guess, to create dashboards, I'm realizing that if you know vSphere, you may or may not have used VROps. And so I'm trying to think, should I make a bunch of small videos that say, hey, if you're used to doing this thing this way in vSphere, this is the way you probably want to do it in VCF ops or VROps. I'm curious, do people think that would be a useful thing, or is this like super boring and old hat for all of you?
I think that would be useful because to me, VROps, whatever it's called this week, right, has been always this tool that's just out of reach from a budgeting point of view. But I know it can go do really cool stuff, but I always need to look up stuff and get my hands dirty and think about just doing simple stuff way too long than it actually should take me. So stuff like that would be really helpful.
Nice. Yeah, I mean, the two things I was thinking about from a coding perspective, again, I haven't decided on this yet, are I personally, I use the Performance Manager API a lot, so I know that really well. And if you want to get data from VROps, though, you'd be using a totally different API. So we'd want to look at something like that. The other thing we'd want to look at is if you want to create a dashboard and if you've never done it before in VROps, it can be a bit daunting. Once you figure out it's not that bad, but there are a lot of random steps. If you want to push your own metrics to VROps, that's a whole other ballgame. But once you figure out, it's actually pretty straightforward. So I was thinking of talking about topics like this, especially from the perspective of someone that's more of a vSphere power user that's jumping into VROps as opposed to someone that's used VROps extensively. So these are things I might be thinking about, Franky, in addition to sort of more, just generally speaking, VCF performance, and scale type stuff.
Oh, definitely. Yeah. And when I was a customer, I had we had access to to that suite, right? And back then it was called something different. But yes, once I downloaded VROPS, I deployed it and just let it cook, right? You just let it bake there for a bit. And how Maarten said, right? It was I was the only BI person at the company. So it was like, oh shoot, now I got to go back and learn this. But if you just let it cook and then use the bare the dashboards that come with it, yeah, as soon as you start seeing the pretty pictures, you're like, oh hey, this isn't bad. And then yes, you jump over to Sample Exchange, right? And the community is always contributing things, and you can just download them and deploy them. And yes, and how you said now with everybody moving over to VCF, right, it comes with the package, so it's included. And yeah, you might as well just deploy it if you can, and then yes, yeah, you'll be able to more easily speak to your management, right? And that's what I used it for. And yes, I was able to jump in there, and when we needed specific troubleshooting, right, then I would jump in there for a longer term kind of thing. And yes, I think it would be extremely helpful. And for anybody watching this, what Ravi, what you just asked, in my opinion, if you have to ask yourself, hey, would this be interesting to somebody? It probably is interesting, and assume it is interesting. Especially how Maarten said, right? If you have somebody that wants to get into using X product, but doesn't even know where to start, and try and see things from a different perspective. I think I think that would be great. Yeah, we'd love to have you back. Yeah, I love it.
We'll see what we can do. And I guess the final parting shot I'll say is, because we're a general performance group, we work on VCF, vSphere, vCenter, ESX, etc. So if any topics of interest come to your mind, Franky, you ping me or Julie, and we'll definitely hook you up with the right people. We have plenty of stuff that we can talk about.
Excellent. Yes. Yeah.
Cool.
See, you shouldn't have said that. Yeah. I'm gonna bug you. Awesome. Okay.
No problem.
Perfect.
Thank you again for
Don,
the opportunity. We
Everett?
appreciate it.
Oh, definitely. Thank you. Thank you. Does anybody have any questions before we wrap this up?
No, this is
Nobody
super
else, nobody
interesting.
else.
Thank you.
Thank you very
Wonderful.
much,
Excellent.
everybody.
Thank you.
Cool. All right. Thank you. Thank you. Thank you. All right.
Bye-bye.
See you later, everyone. All right. Take care.
Yeah.
Thank you.